Hello, we are eco-engineers providing our recommended retrofits to handle the projected increased volume of water to 34.5 million gallons per day flowing into the city of West Columbia's treatment facility. Our team members are Riva Maddy, Ali Fardoon, Garrett Huckabone, Kana Dowdy, and Attila Falby. The suggested system upgrades we'll be going over are rapid mixed basin coagulation process, flocculation basins, sedimentation basins, filtration system, and disinfection system. As mentioned before, the city of West Columbia's treatment plant is not suited to handle the projected volume of 34.5 million gallons per day. So in order to handle the projected influx of water, the volume of the rapid mixed basin also needs to be increased to 1,600 cubic feet. The current 7.5 horsepower mixer is not adequate for the projected expanding capacity and will need to be upgraded to a minimum of 37.5 horsepower. The feed rate requirements will increase so that the average alum feed will be 5,761 pounds per day with a maximum of 11,523 pounds per day, and the average sodium hydroxide feed will increase to 4,043 pounds per day with a max of 8,086 pounds per day. Additionally, an average of 9,804 pounds per day and a max of 19,609 pounds per day of aluminum hydroxide and sodium sulfate will be producing mass solids in a coagulation reaction.
Flocculation basin upgrade design. The proposed upgrade to the flocculation system consists of 9 basins of 3 stages each for an increased volume of 16,200 cubic feet per basin. The basin dimensions are 45 feet long, 24 feet wide, and 50 feet deep. An augmented flow rate up to 43.6 million gallons per day for redundancy and maintenance requirement in accordance with 10 state standards. For a mean fluid velocity of 1.25 feet per minute and a wheel load rate of 5 cubic feet per minute, the upgrade input power requirement are Stage 1, 630 watts, Stage 2, 206 watts, Stage 3, 13 watts, or 849 watts per basin. The total power requirement for the new flocculation system is therefore 7.61 kilowatts. We are lastly proposing to replace the damaged working beams with a fiber-reinforced plastic beams for its durability, resistance to rough environments such as flocculation area of water treatment plants. Thank you.
So for our current sedimentation basin design at 34.5 million gallons per day, we have a dimension of 152.5 by 30 by 15.11 feet. Our detention time we calculate to be 1.8 hours, which is less than the 4 hours required. Our total influent is 1,200 feet. Our SOR was calculated to be 1.05 gallons per minute per square foot, which is greater than our 0.5 maximum. And our horizontal velocity was calculated to be 1.41 feet per minute, which is greater than our 0.5 maximum horizontal velocity. So for our proposed upgrades, we want to increase the number of basins to 9 and change the dimensions for each basin to 120 by 30 by 23.72. This gave us a new detention time of 4 hours, a horizontal velocity of 0.5 feet per minute, and a wire length of 1,725 feet. We got a new surface area overflow rate of 0.74 gallons per minute per square foot, and an additional upgrade so that way we can meet that maximum SOR is we want to use plate sailors at 45 degrees to the surface, which allows the effectiveness to increase the settling area of the surface by 2.5. And with this additional upgrade, it will reduce the SOR below zero point 0.5 gallons per minute per square foot standard. Thank you. For our existing conditions, we had 20 inches of anthracite, 9 inches of sand, and a total media depth of 29 inches. Our filter dimensions was 40.5 by 13 by 11.5 feet. Our surface area per filter was 526.5 square foot for each filter, which led to a total to be 2,632.5 square foot and a hydraulic loading rate of 6 gallons per minute per square foot. So for our filtration design upgrades, we calculated that we have an insufficient future flow of 23,958 gallons per minute. So for our solutions, we came up with two. Either add 4 additional filters, making it a total of 9 filters, and using a hydraulic loading rate of 5.1 gallons per minute per square foot, or to use 12 filters in total when using a hydraulic loading rate of 4 gallons per minute per square foot, and this was given the 10 state standard. So for our final recommendation, we want to install 4 new filters with a total of 9 filters, one using 5.1 gallons per minute per square foot hydraulic loading rate. The reason we chose this option was because it would optimize the cost and the space. Uh, and with 9 filters, the existing pumps should be sufficient for backwashing. Thank you.
Disinfection system upgrade for future capacity. Our existing system operates at 22.5 mgd with 3 clear wells in parallel for chlorine disinfection. This system generates hypochlorite on site, but the equipment has reached the end of its useful life. To meet the future demand, we are transitioning to bulk sodium hypochlorite with a concentration of 6.25% sodium hypochlorite and a density of 1100 kilograms per meters cubed. Looking at the flow rate, it increased to 34.5 mgd. Looking at clear well retention, based on tracer studies, the T10 over TD ratios are 0.43, 0.51, and 0.58 for clear wells 1, 2, and 3. Looking at chlorine decay, we accounted for 50% chlorine loss per clear well when determining dosing requirements. And our design ensures that the required CT value is met for Giardia and viruses reduction. We calculated the residual chlorine concentration needed at each clear well exit to achieve the target disinfection level. To maintain the required chlorine dose, our calculations show that each cubic meter of sodium hypochlorite contains 32.73 kilograms of chlorine. The system will use a daily bulk of sodium hypochlorite volume sufficient to meet the new disinfection demand.
And here we have our final RFP plan layout. Down below in the middle of the plan is where the new rapid mixing basin will be added, in addition to 5 new chemical storage tanks. To the right of that, you can see the additional flocculation basins, sedimentation basins, and filters. Four of each will be added alongside the existing ones. Finally, directly in the middle of the plan, you will see we will be adding a hypochlorite storage facility. Thank you for watching.